Good afternoon, students. Myself Pragnesh Polara from Om Engineering College, Junagadh. Today we have met here to discuss some methods and important methods which related to which examples are frequently asked in GTU exams. So we just quickly move to the all the basics about multiple integration, especially double integration, and then we will discuss some example which are most important for exam point of view. Let us look at the PPT. Then here this is the double integration over general regions. So in this section we will learn how to use double integrals to find the areas of regions of different shapes. Before I move to first, we will discuss. This is easy example to evaluate double integration over x plus 2y dA. dA means dx into dy, where d is the region bounded by the parabola y is equal to 2x square and y is equal to 1 plus x square. This is the simple example of double integration. So first we need to find the limit of x and y, and to find the limit of x and y, first we need to draw the diagram from which we will decide the region of the area D, and then we will find the limit of x and y. So here we have parabolas y is equal to 2x square and y is equal to 1 plus x square. If we look at the diagram, then both parabolas intersect at -1 2 1 2, so we will get x is equal to plus or minus 1. And here note that the region D is the region, but is the type 1 of region. Okay, so here we can find the limit of x is -1 less than or equal to x less than or equal to 1. This is type of 1 because here we have fixed the limit of x, which is, and how to fix the limit, this is the most important thing. From the diagram, if we look at the left hand side of the region which is bounded by x is equal to -1, and the right hand side limit of the region is bounded by x is equal to 1. So if we fix the limit of x, then -1 less than or equal to x less than or equal to plus 1, and here y is depends on x, so limit of y is in the terms of x. So here 2x square less than or equal to y less than or equal to 1 plus x square, because 2x square y is equal to 2x square is the lower parabola and the y is equal to 1 plus x square is the upper parabola. So limit of y is equal to 2x square less than or equal to y less than or equal to 1 plus x square. So here this is the upper boundary. Okay, y is equal to 1 plus x square. So now we are able to solve this example x plus 2y dA, where limit of x is -1 to 1 and y is 2x square from 1 plus x square x plus 2y dy dx. Here note that we have first write dy then dx. That means the inner limit, which is from 2x square to 1 plus x square, is the limit of y, and the outer limit, which is -1 to 1, is the limit of x. So here first we will integrate this with respect to y. So if we integrate x plus 2y, then with respect to y, then we will get xy plus integration of 2y is y square. So xy plus y square, where the limit is 2x square to 1 plus x square. If we put the limit here in the integration, then we will get after the calculation we will get it is integration over -1 to 1 minus 3x raised to 4 minus x cube plus 2x square plus x plus 1 into dx. and then easily we can integrate with respect to x, and we will get minus 3. Integration of x raised to 4 is x raised to 5 upon 5 minus x cube. Integration of x cube is x raised to 4 by 4 plus 2x cube by 3 plus x square by 2, and integration of 1 is x. And by putting the limit from minus 1 to 1, we will get, after the calculation, the answer of this double integration example is 32 by 15. Okay, and note that when we set up a double integral as in example, it is essential to draw a diagram, because without drawing diagram in such an example where limit is not given but limit is in the diagram, after drawing diagram we can find the limit. If the limits are already given, then it is okay to solve the example directly, but when there is limit not given, we first need to draw the diagram, and after that, with the help of that diagram, we will find the limit. Okay, so before we move the another example, let us look at one more example which was asked in GTU exam. Let us look at the example. The question is, evaluate integration 0 to 1 and 0 to x, which is very simple example of double integration x square plus y square dy dx. This example was asked in January 2009. Okay, as I discussed here, the limit of x is 0 to 1 and limit of y is 0 to x is already given, so we are not supposed to draw a diagram. That is alright, because if we draw the diagram, then we can imagine the shape of this region, but to calculate this, to evaluate this integration, we did not need to find the draw the diagram. Okay, so we will solve this example without drawing diagram. Here first we will integrate this with respect to y first, and then with respect to x. So here, which is equal to 0 to 1, integration of x square with respect to y is x square into y plus y cube by 3, and the limit of 0 to x. Okay, so if we put the limit here, then we will get, first we will put the upper limit, then here we will put x, then here x. So x square into x is equal to x cube plus here x cube by 3 minus, when we put the lower limit y is equal to 0, then both this term is equal to 0, so here I will put 0. So after all, we will get x cube plus x cube by 3 into dx, and then we will integrate this with respect to x. So we get here 0 to 1 x cube plus x cube by 3 dx. So this is equal to 0 to 1, this is equal to 4x cube divided by 3 dx. Okay, so 4 by 3 is constant, so 4 by 3 is here, and 0 to 1 x cube dx, and by integrate this one we will get 4 by 3 here, x raised to 4 by 4, and the limit is 0 to 1, and if we put the limit, we will get is equal to 4 by 3, and here when we put the upper limit, this is 1 raised to 4 by 4, so 1 by 4, and when I put the lower limit 0, then it will be 0. So I will get only 1 by 4. So after all, the answer is 1 by 3. So this is the simple example of evaluating by double integration, and this example was asked in January 2009. So in this way we can evaluate the integration. Let us look at the another example, and with in which we will draw the diagram and then we will fix the limit of integration. So let us look at one more example. Evaluate double integration of x plus y dy dx in region bounded by x is equal to 0, x is equal to 2, y is equal to x, and y is equal to x plus 2. This is the example which was asked in January 2009 as well. Okay, so here the limit is not given clearly, but it is given in the equation form. We can imagine from the equation directly that here the limit of x will be from 0 to 2, and the limit of y is from x to x plus 2. But here we will draw the diagram first to understand what is going on in the region. So first I will draw the diagram. First I will draw x is equal to 0, that is our yx, okay, and then x is equal to, suppose this is 1, this is 2, so this is x is equal to 2, okay, this is our second line. Then the third line is y is equal to x. We know that the y is equal to x is the line which is passing through the origin. This is, for example, 1, 2, this is our origin. So the line is passing through 0, 0, 1, 1, 2, 2. So we will get this is the equation, this is the line y is equal to x, and then the next line is y is equal to x plus 2. Remember the chapter of straight line. This is the equation of type y is equal to mx plus 2. This is the equation of line which is making intercept of 2 on y axis and passing through 0, 2. So here this line is like that. This is y is equal to x plus 2. This point is 0 and 2. So after all, our region bounded between these four lines is here. This is the shaded area. So if when we going for the limits of x and y, we just need to see about the region which is bounded between our given expressions. So here the region is bounded between, first when we fix the limit of x, then we need to consider from the left hand side to right hand side. Here our left hand side limit of x of our region is bounded from here here, so left hand limit of our region is 0 and right hand limit of x is 2. So here 0 less than or equal to x less than or equal to 2 for this bounded region. And here we have fixed the limit of x, then the limit of y is in the format of x. So when we want to fix the limit of y, we need to consider from the lower limit to upper limit. So here lower boundary of our region is at y is equal to x, that means this line. So lower limit of y is x less than or equal to y, and upper limit of our region is y is equal to x plus 2, that means this line. So this is the upper limit of our region. So after all, we will get the limit of x is 0 to 2 and limit of y is x to x plus 2. So here we can see our region. Okay, so now we can integrate our example, evaluate our example with the limit of x 0 to 2 and y x to x plus 2. So this is equal to double integration from 0 to 2. Our example will be formed like this: 0 to 2 and limit of y is x to x plus 2, and we need to evaluate x plus y and dy dx. Okay, so now it is very easily. First we will integrate this one with respect to y, so we will get xy plus y square by 2, here x plus 2 dx, which is equal to 0 to 2. When I put the upper limit